We all know about valency, but a few of us know what is valency factor. As valency says, the number of charges atoms either transfer or share in order to attain stability. On the other hand, valency factor says how the charges are redistributed in a redox chemical reaction. For example, when ethane will burn in oxygen to produce carbon dioxide and water, how the charge on per mole reactant elements will be redistributed to the product elements. That we can come to know by valency factor or N factor. So, N factor says the change in oxidation state of reactant elements per mole in a redox chemical reaction. So, to define N factor, we can say that valency factor or N factor tells us the number of electrons gained or lost by 1 mole of a chemical entity in a redox chemical reaction. Let me take another example to make it more clear. In the reaction between zinc and copper sulfate, zinc sulfate and copper are produced. In this redox chemical reaction, zinc is losing 2 electrons and its oxidation state increased from 0 to +2, whereas copper gains 2 electrons and its oxidation state reduced from +2 to 0. So, 2 electrons that zinc loses to oxidize, copper gains to get reduced. So, the number of oxidation is 2 and the number of reduction is 2. Now, by using the N factor formula, I calculate the N factor of this reaction is 1. Now, I hope you understand the importance to know the calculation of valency factor or N factor in chemistry. It is very important to know the calculation of N factor in chemistry. The first and foremost reason is that if we want to get the equivalent weight or mass of a substance in a compound, we need the N factor. The molar mass has to be divided by the N factor, then we get the equivalent mass or weight of any substance. Or if we want to get the number of gram equivalent of elements in a chemical reaction, we need the N factor. The mass has to be divided by the equivalent mass, and to get the equivalent mass, we must know the calculation of N factor. If we want to know the normality of a solution, then molarity has to be multiplied by the N factor. And in titration process, we also need to apply the concept of equivalent mass, and to obtain the equivalent mass, we need N factor. So, I hope now you understand that why should know the calculation of N factor or valency factor in chemistry. I would like to discuss with you the different formulas to calculate the valency factor of molecules, compounds, acids, bases, salts, oxidizing or reducing agent, and the N factor of a disproportionate chemical reaction. How does the oxidation state of a molecule of an element changes in a chemical reaction? That depends on its valency factor or N factor. And the calculation of N factor of molecules is very simple. We simply have to multiply the atomicity of the molecule to its valency. For example, hydrogen, a diatomic molecule. When the valency of hydrogen 1 is multiplied to its atomicity, we get the N factor of hydrogen molecule, that is 2. For oxygen, the valency 2 when multiplied to its atomicity 2, we get the N factor of oxygen 4. Same as nitrogen. Nitrogen with valency 3. When the valency of nitrogen is multiplied by its atomicity 2, we get the N factor of nitrogen 6. But phosphorus has 4 atoms in its molecule. So, when phosphorus valency 3 is multiplied by its atomicity 4, we get the N factor of phosphorus 12. And chlorine with 1 valency and 2 atomicity has its N factor 2. To calculate N factor for compounds, we have to look for its nature. Calcium oxide. Calcium oxide is a metallic oxide, and metallic oxides are basic in nature. On the other hand, nitrogen dioxide and sulfur dioxide, these are non-metallic oxides, and non-metallic oxides are acidic in nature. Calcium oxide, for being basic in nature, when react with an acid in aqueous solution, it will displace the hydrogen cation from the acid molecule and form salt and water. And the number of displaced hydrogen cation is its N factor. Likewise, when nitrogen dioxide and sulfur dioxide or non-metallic oxides or being acidic in nature react with a base in an aqueous solution, they will displace the hydroxyl anion from the basic molecule, and the number of displaced hydroxyl anion is its N factor. So, when calcium oxide react with hydrochloric acid in aqueous solution, it will displace the hydrogen cation and form calcium chloride and water. As 1 mole of calcium oxide displaces 2 hydrogen cations, then its N factor is 2. When nitrogen oxide will react with a base in aqueous solution, here it is sodium hydroxide, then nitrogen dioxide will displace the hydroxyl anion from the basic molecule to form sodium nitrate and water. As 1 mole of nitrogen dioxide displaces 2 hydroxyl anion. For this reason, its N factor is 2. Same way, sulfur dioxide, when react with sodium hydroxide in aqueous solution, it will displace the hydroxyl anion to form sodium sulfide and water. As 1 mole of sulfur dioxide displaces 2 hydroxyl anions, its N factor is 2. So, when a compound is metallic, the number of hydrogen cation it displaces from an acid molecule is its N factor. And when the compounds are non-metallic, the number of hydroxyl anions they displace from a base molecule, that is its N factor. How do the ions change their oxidation state in chemical reaction? It depends on their ionic charge. And for N factor calculation, we have to consider the mode value of their ionic charge. For cations, it is the cationic charge. For example, cupric with +2 charge. For N factor calculation, we have to consider only the mode of +2, that is 2. Ferrous. For N factor of ferrous, we have to consider the mode of +2, that is 2. Same way, manganese has N factor 3 and ammonium ion has N factor 1. And for anions, we have to consider the mode value of the anionic charge. For example, chloride with -1 charge. For N factor of chloride, we have to consider the mode value of -1, that is 1. Same way, oxide has N factor 2. Bromide with -1 charge. For N factor, we have to consider the mode of -1, that is 1. The chromate anion with -2 charge. For N factor calculation, we accept only 2. And same as for the permanganate ion. Permanganate ion with -1 charge. For N factor, we have to consider the mode value of -1, that is 1. To calculate N factor of any acid, we need to look for its basicity. Basicity means the number of replaceable hydrogen atom in an acid molecule. Again, N factor is the number of replaceable hydrogen atom present in 1 mole of any acid. Phosphoric acid. Phosphoric acid has 3 hydrogen atoms. In aqueous solution, it displaces all the 3 hydrogen atoms and dissociates into phosphate anion and hydrogen cation. As it displaces all its 3 hydrogen atoms, so it is a tribasic acid with N factor 3. Phosphorus acid. It also has 3 hydrogen atoms. But are all these hydrogen atoms replaceable? Let's see. In the acid molecule, one hydrogen atom is directly bonded to the central phosphorus atom and it is a strong bond and it cannot be replaced. Only the hydrogen atoms which are in hydroxyl group, they are replaceable in aqueous solution. So it is a diabasic acid and furnishes 2 hydrogen cation in aqueous solution. So its N factor is 2. Next, hypophosphorus acid. In the molecular structure of hypophosphorus acid, we see that 2 hydrogen atoms are directly bonded to the central phosphorus atom. So they are not replaceable. Only the hydrogen atom which is bonded to the oxygen is displaced in aqueous solution, furnishing hypophosphite anion and hydrogen cation. So it is a monobasic acid with N factor 1. So I hope it is clear to you that it is not the number of hydrogen atom present in an acid molecule, but the number of replaceable hydrogen atom which determines the basicity, hence the N factor. Now let's see some of the organic acid. Formic acid. The molecular structure of formic acid shows the central carbon atom has a direct bond to one hydrogen atom. This hydrogen atom is not replaceable, but the hydrogen which is bonded to one oxygen atom, that is replaced in aqueous solution. So it is a monobasic acid, hence its N factor is 1. Acetic acid. Another weak organic acid. There is a methyl group in its molecular structure. Not any of these 3 hydrogen atom is replaceable because they are all directly bonded to the carbon atom. The hydrogen which is bonded to the oxygen, that is replaced in aqueous solution. Though acetic acid has 4 hydrogen atoms, but it furnishes only 1 hydrogen cation in aqueous solution. So it is a monobasic acid, hence its N factor is 1. The last example I would like to give you as an exceptional case, that is of boric acid. Boric acid, in its molecular structure we see that there are 3 hydroxyl group and this 3 hydroxyl group is bonded to the central atom boron. But in aqueous solution, no hydrogen atom is displaced. Rather, it dissociates the water molecule and attract one hydroxyl group and combine it to itself to form tetrahydroxyborate anion. So in aqueous solution, it furnishes only 1 hydrogen cation. Hence, its N factor is 1. To find N factor of a base, we have to look for its acidity. Acidity means the number of replaceable hydroxyl anion. So the N factor for a base is the number of replaceable hydroxyl anion present in 1 mole of any base. For example, calcium hydroxide. Calcium hydroxide has 2 hydroxyl group in its molecule. In aqueous solution, it displaces 2 hydroxyl anion, so its acidity is 2. As acidity represents the N factor, so its N factor is 2. Aluminium hydroxide. Aluminium hydroxide has 3 hydroxyl group and it displaces all the 3 hydroxyl anions in aqueous solution, so its acidity is 3 with N factor 3. Our next example is ammonium hydroxide. Ammonium hydroxide has only one hydroxyl ion in its molecule that gets displaced in aqueous solution. So, it is a monoacidic base with N factor 1. Ammonia. Ammonia is a weak base and it has no hydroxyl anion in its molecule. But in aqueous solution, it attracts hydrogen cation from the water molecule and itself combined with the hydrogen cation to form ammonium cation. Further, it combined with a hydroxyl anion to form ammonium hydroxide. As it furnishes only one hydroxyl anion in aqueous solution, so it is a monoacidic base with N factor 1. To find the N factor of salts, we have to consider the total cationic charge or total anionic charge in a salt molecule. To explain, I have taken sodium bicarbonate as example. A salt molecule is composed of metallic cation and non-metallic anion and cationic charge balanced by anionic charge to make the molecule neutral. So, salt molecule bears same number of positive and negative charge. For N factor of a salt, we have to consider the mode value of either the total positive or total negative charge. So, the N factor of sodium bicarbonate is 1. Our next example is zinc sulfate. Zinc cation bears positive 2 charge and the sulfate anion bears negative 2 charge. Positive charge equals the negative charge. So, the N factor of zinc sulfate is the mode value of either the positive or the negative charge, that is 2. Next, how to find the N factor of an oxidizing agent or a reducing agent. An oxidizing agent gains electron to get reduced itself and oxidize other. For example, potassium permanganate and potassium dichromate. Whereas, a reducing agent loses electron to get oxidize itself and reduce other. For example, ferrous sulfate. And the difference in charge in a chemical reaction is its N factor. This and how to calculate the N factor of a disproportionate chemical reaction that I am going to explain in my next video.